Hello, my name is Christina Shea and I'm professor at ETH Zurich in Switzerland, and I'm here with Ali Bloch-Peidash, who worked on her PhD in design heuristics for additive manufacturing. And we'd like to present you a bit about this work. So the first question is, why do we need design for additive manufacturing methods? There are several methods out there for restrictive DFAM. So for example, catalogs of process restrictions, optimizing the AM fabrication process, or designing complex geometries, for example, through structural topology optimization. And what Ali looked at in her PhD are opportunistic DFAM methods. So the question was, how can we provide a method that allows people to understand better how and when to consider AM in their design projects, to transfer AM knowledge to them, to improve their designs for AM, and finally, to break out of the conventional mindset and bias imposed by conventional manufacturing processes. So what she came up with is 25 design heuristics for AM in 8 different categories. These categories include part consolidation. So this is a typical example in AM. So for example, consolidate parts, reduce assembly time. And in this case, it's an air vent that's consolidated. Or for example, in material distribution, so using structural topology optimization to optimize the flow in a water manifold so that you can reduce vibrations. So these categories include also customize, convey information, material, embed and close, lightweight, and reconfiguration. So now I'll hand it over to Ali, who will present to you the cards and the heuristics.
Great. So I'm Ali, hello. And we came up with these 25 heuristics, and then it was the question, how do we go about conveying these to people? How do we bring them this knowledge other than just handing them a list of heuristics? And we came up with the idea of creating cards, and our cards are based on those that were developed by Yilmaz and Seifert, the 77 design heuristics. And on each card, you have the front and you have the name of the heuristic, the number of the heuristic. You have a short description of what the heuristic is, what it means. You have an abstract visual of what this heuristic could mean. You have the category. And then on the back, you have, again, the title and number. And then you have a specific example from either literature or industry. And then you have an image representing this on the side. So we also found, though, that additive manufacturing is something that a lot of people haven't visually seen before or haven't experienced, and that it would be very useful to have something that they could touch, that they could play with to help them understand. And so we also came up with 25 objects to go with each of the heuristics. And like I said, they're a physical representation. It allows you to experience the heuristic tactically. We try to make them domain neutral when possible and similar within the same category. And on the next slide, we have some specific examples of how these work together. So here's one: use multiple materials to achieve graded material properties. What does that mean? Well, that means that in some additive manufacturing methods, you can mix materials in a gradient. And here's the idea. Okay, think of how you can mix these materials either in a gradient or in a 1-0 fashion to get you to the material properties that you want, that you maybe wouldn't otherwise be able to achieve with a single material. So the real world example of this is a socket that's customized to a socket for a prosthetic that's customized to the patient, that was developed at MIT using a multi-material printer. And then our physical example at the bottom is something that comes out of the lab. It is a lattice optimization using different materials. So you see here 3 cantilever beams. This is printed using only 2 materials, but in the middle beam, you can see that the materials are mixed. And this then gets you completely different material properties and a different behavior of the cantilever beam when you do that. Then on the next slide, we have allow movement with small interconnected parts. This is a big advantage of AM, that you can create something like a chainmail, for example, that would, using conventional methods, be very difficult and take a lot of manpower and effort to get to. And here you have an example of a brace with a small interconnected section to make it flexible for the patient. And then at the bottom, we have a flexible triangle system that was developed by a student at our lab. So we didn't just create these and do nothing with them. We looked to see, do they actually help people with anything? So we did some controlled validations. So we ran some user studies with novice designers. Novice designer is code for engineering students. And we also ran with some industrial designers. And we found through these controlled studies that when the students were using the cards and the objects, either together or separately, we found that their ideas were more novel. They had created a wider variety of ideas, and they also created more ideas when they had access to the cards, even though they had to take in more information during the design time. We then also said, okay, great that it works with students, but students are not the real world. So we then also did some workshops with companies. So we worked with an automotive supplier. We worked with a manufacturing machinery company, and we also worked with a construction machinery company. And we ran 3 different workshops, and all together we had 19 participants. They all had engineering backgrounds. And we ran a 3-hour workshop with them. So they came up with a task that they defined themselves. This was a real world task that they had at their company. We shortly introduced the DHAM. We ran a 1-hour workshop with them, and then we discussed the results and asked for feedback on the DHAM. And they came up with 4 different big advantages. The first is that they thought they were really good for teaching others about AM. So not just themselves learning about it, but they said, hey, I could really see this being useful when I need to explain to my boss why we should invest in an AM machine, or why we should maybe do this R&D project related to AM. They found it very useful. They also said it made a good checklist for something at the sort of last stage of the project. If you have before you go to design freeze, you can just page through the cards at your desk and see, okay, is there anything else that we could still integrate into this project? They also said that having the cards together with the objects was really fantastic for them. They said, when I have the text there and then I have an object that I can physically feel in my hands, they found that was sort of the best of both worlds. It helped them really explain to their other teammates, and they could pantomime what they wanted. They really enjoyed working with the 2 things together. And then finally, like we saw with the students in the controlled studies, they also had the feeling that they were creating more ideas, that they were more novel, and that they were creating a wider variety of ideas. So if you want to use these yourself, what can you do? Start by using an existing product to redesign. Design heuristics are concept modifiers, not concept generators. It's really best to start, especially as a beginner, with a redesign task. You don't need previous experience with DFAM. A lot of our students had 0 experience, and they still came out with great results. But if you have a basic awareness of AM, it does help a little bit. What's also very good, especially if you're working in a group, lay the cards out in a gallery, a 5x5 gallery on the table. And if you have the objects, lay these with them. Like I said, the industry partners found the objects extremely useful. And if you are at a company, something that they also said would be really great is to start augmenting the DHAM with your own examples. Or if you're someone who's running a workshop for customers consulting or something, start augmenting with examples that you've seen. And then finally, the workshops don't need to be long. 2 to 3 hours we found was plenty of time to get to know how to use the DHAM and run an ideation workshop and discuss the results. You really don't need a lot of time or previous knowledge in order to do this. So we hope you use them. And if you'd like, you're all getting a set of the cards as far as we know, but also feel free to go and download more copies of the cards if you want to print more of your own, and also copies of the objects, the STL files for the objects, if you would like to get a set of those as well. Thank you.
Thank you.